Over to you, Mike.
All right. Hey, everybody. Thanks for having me again for the Azure User Group. Pretty excited to be back and really excited to talk about this topic. So we're going to be adding some chaos to our pipeline and a little bit of load too. So let's kind of jump right in. If you're not familiar with me, Mike Douglas, solution consultant and director of our delivery engineering group at Netapp. We're basically a solution consulting company. Helping organizations do a lot of different development. You see, really not going to touch on a lot of these here, but if you want to reach out, there's my Twitter. Feel free to talk to me. I think I've got direct chat on and there too. The one cool thing, or I don't know, I think it's fun, I'm kind of most proud of here is the work that I do for a robotics club here in Omaha, and really helping 4th through 8th graders do robotics, and we compete competitively. We competed last week, and we've got another meet this week, so pretty exciting doing that. So yeah. All right, so I don't know if this is normal, but I personally get almost more excited about the non-functional requirements of a project than the actual functional requirements, that we're building from a development standpoint. And I think that's what really kind of shows what it's got me excited about these two new tools. We're talking about Azure Chaos Studio and the new Azure Load Testing Service. Both of these are in preview. And both of these I've been trying out, getting a feel, taking them a run. So I'm here to really showcase some of the stuff that I've learned with this, and really hope kind of get you guys excited about the services too. By no means going to say I'm any kind of expert at all in any of these. Again, they're still in preview and still learning them too, but some really, really exciting stuff. So let's go ahead and jump right in here. So in talking about pipelines, just kind of looking at what pipelines do today. I'd say, in the past, pipelines were a big deal. I think now they've just become kind of the given. They help us deploy more effectively, efficiently. It's helped us really do smaller batches, to deploy more frequently, do faster deployments all the way through to production, really improve quality. We can do things like run functional tests there. So everything is really good, right? We're deploying, we're building, we're deploying. The thing that's not covered by here is what happens if something goes wrong. So in this case, how confident are you if something goes wrong in your app? And that's something we're not really doing anything about from our typically from our pipelines. In addition, it's how well will your application work if there's unexpected changes? Maybe all of a sudden you get double the users on your site. What if something goes down? What if something fails, like a service, VM? What if a whole cloud region goes out? That'll never happen, right? So, those types of things, will your application just crash? Will it function like normal? Will it degrade but still be functional? And so those are all the types of things. But the key thing is how do you know? Because I think one of the things is oh yeah, we built it that way. We'll test it eventually, or maybe you've had some sort of catastrophic event, and then all of a sudden, you're able to test it there. But in this, what I'm hoping to kind of show is how we can actually be more proactive, really about this stuff. So let's keep jumping in here. So before kind of going into this, I just wanted to kind of do a quick kind of level set with just resiliency, because I think that's one term, at least I know I had a misunderstanding for a long time with this. But the first question is, can you prevent failures? Just asking you guys, can you prevent them? No, right? You can't prevent failures. They're going to happen, even in the cloud, right? They're still, below all the paths and all the services that Microsoft provides in Azure. There's still hard drives, there's still CPUs and all those things, and those will eventually fail. So, but the key is, can you prevent outages by those failures? That's really the key there. And so resiliency really is that ability of a system to like recover from those failure and continue to function to avoid any kind of downtime or data loss. So that's really kind of the key that we're looking for here. Not that we're going to figure out a way to prevent failures, because if we have redundancy, the whole reason we have redundancy is because something's probably going to fail. All right, so let's talk real quick a little bit about Azure and resiliency. Microsoft has become very good at being resilient. They offer a lot of capabilities and tools. There's things like that are offered like SLAs with all the different services of how many nines might a VM might be 99.5, but you can do things to actually increase that SLA on things. There's tools like monitoring and reporting, automated remediation. We can do things from a security standpoint. A lot of different options. And the good thing is a lot of these are almost as easy as a checkbox. One of the key things here that I think Microsoft has become really good at too is not just even preventing the failures, but if they do have something wrong and they do have something come up, one of the things that they've done a really good job is being transparent and being kind of open about like what happened and reporting those things, I think, which has really helped continue to build trust from as a cloud vendor there. Across some of the more specifics, like for infrastructure as a service, there's things called availability sets. So that's if you're if you have VMs or even some of the PaaS services, that Microsoft won't reboot them all at the same time, so that all of your instances go down. You can do them across like racks and across different zones, and that's where that availability sets is. Availability zones is another nice feature. Like they will actually, a region, an Azure region is actually made up of 2 different data centers, or probably even more than that, some of them, but it's made up of multiple data centers. So what they'll actually do though is tie those together. So if you have, let's just say like AKS, where you have multiple nodes, you can create those nodes across availability zones. So even if a data center goes out, your other node is in a different availability zone, and that'll actually help keep your service up unless the whole region goes down. But it definitely increases that. Unfortunately, the one region that did have an issue, an outage, did not have availability zones, so that made it a little harder. Their region pairs, again, another part of resiliency is every region in Azure, if you're not aware, has a kind of a paired region that a lot of the redundant systems, if you configure like storage and geo redundancy, those will, in like Key Vault, will automatically come up in the new region if Microsoft kind of says it, thinks it's down. So you want to configure your different region with that paired one, so that you get some of those benefits without having to do anything. From like a platform as a service, some of the premium SKUs that they have offer a number of increased resiliency options, and then just even configuring multiple instances. That's one thing we always try to do, especially in production, is we basically create it with multiple instances, and then that kind of falls back to that availability sets and stuff, so that make sure that those are all up and running. So that's kind of Azure and some of the resiliency. What about your application? We just showed how Azure is resilient, but is your application? And that's really what we don't know at this point, right? And if you think it is, like, how do you know? Have we ever tested it? Have you ever tried to do something to see if it actually does do what we think it's going to do? Those are the kinds of things that we're going to show here in the next few minutes. A couple things you can do from your application. One is called the failure mode analysis. So this is something we typically do at like kind of a sprint 0 time frame. We start this, and then it kind of is a living document throughout a project. What this does is helps you kind of go through your entire like infrastructure to kind of identify like where could things go wrong. Like if the central region went down in this application, what would you have to do there? We have Traffic Manager that's a global service, so that can help us out. But those types of things, in each one of the services we could break down. We'd fill this all out. And even though this is manual here, this is still a really good source for what we're going to show with a tool called Chaos Studio. All right, so we talked a little about resiliency. So now let's talk about chaos. So what do you think about when you think about chaos? Is it like The Witcher? Have you guys ever seen that show or the game? Chaos is a really big part of that. But no, you might be thinking of your last project. Hope not, or your last deployment. What could that be with chaos? So in this case, we're actually talking about chaos engineering. And so if you haven't heard of that, what chaos engineering is really an intentional way to inject faults into your system to ensure that the application is still working. So we're actually going to try to make things go wrong. And you might be saying, well, why do you want to do that, right? We spend all of our time, Glenn talked about doing networking. Like, you're going to spend time keeping things up and making it, not fail. So why would we want to then go start making things fail, right? Well, we don't want to actually fail. We want to have those faults and failures help keep us from the outages. So we're not trying to make outages. We're just trying to make sure if something does go wrong, we've actually tested it and know that it's not going to have that outage. One of the companies that I think really kind of made this popular is Netflix, and they're kind of simian army. And chaos engineering is really, or the chaos monkey, I should say, is the part of that army that really became popular with. And they don't just do it in like a test environment. Like, they're actually doing it in prod just because they have nothing else that scales that much. So that's really the only place that they can try these things out. So it's pretty interesting, I think. So with this, we're going to actually talk about how we can use a new tool in Azure called Azure Chaos Studio to make some chaos. So what is Azure Chaos Studio? So Azure Chaos Studio is a way to create what they call chaos experiments. And those experiments are really a way to, it's really what we want to inject into a fault, and then making sure that it's still working. So the big thing is an experiment. An experiment is really this whole process here of injecting one or more faults, and then making sure that the application is still working. You have what's called targets. A target is really any of the Azure resources that we're going to be using in the experiment. And the nice thing is, you can't just pick any of them that you want to. I can't just be a rogue cloud engineer and say, yeah, let's just go ahead and try this on production. You actually have to enroll in the Azure Chaos Studio, the different resources there. So you do have to set them up, so you can't just pick anything you want to, which would be more fun, but probably have to be looking for jobs a lot more. And then selectors are a way to, instead of just choosing like a single resource, you may want to say, hey, I want to do this against all the VMs in like my East US region. You can create a selector to say that, and it'll basically apply the same thing to all of those, so that you can do that there. And then the last thing here is the faults and actions. So this is really what we're actually going to be doing as kind of the experiment. So let's talk a little bit more about what those faults are. Again, these are to kind of verify that the system can handle those disruptions. There's different types of faults. So the first one is destructive. So that might mean we shut down a VM and see how your application works, or we kill a pod, or do something that makes something go away in your system that, where the system works better if it's there, right? Hopefully it keeps working without it, but that's exactly what we're trying to test. The other thing is you can apply pressure. You can, better work. The applied pressure is more like if we have like CPU pressure, that would be like, let's run the VM at like 95% and see how the system works. I know my laptop doesn't work that well when it gets that. So it's nice that you can, not simulate it, but you can actually create that chaos there to do that. Other things like latency, maybe we need to simulate like a 3G network, or just, if you have kind of a wide area network and you have remote offices, like how do you do that? Because things tend to work a little bit different in your home office than they do in the remote offices, just from a latency perspective. And then another one is just configuration changes, right? And that can cause a lot of chaos of just sometimes making a configuration change on accident. All of a sudden, breaks everything. I'd say probably the most of the cloud outages probably aren't these first three. Most of the cloud outages are probably caused by this fourth one here, just a accidental configuration change that somebody forgot a where clause and applied it to everything. So so those are all the different types. Might be thinking, okay, so what are those different faults? So there is I think 27 or 28 different faults come out of the box. Currently, you can't create your own yet, but that is something they're working on. But there's kind of two types. There's this delay fault, or a delay, which isn't really a fault. It's just kind of a wait period that you want to do maybe while a fault is being implemented. And then there's the different faults. And then each fault kind of falls into a different category. Some of them are direct. So if you're thinking about Azure, like you can do like a direct ARM, the Azure Resource Manager API. You can use those to like shut down a VM, and you don't have to have any kind of agent anywhere. Chaos Studio can just go do that through the ARM API. Then there's some that require an agent. Like if I want to kill a process on a VM, that's going to require this Chaos agent to be on there to actually do that. And then there's some other agents out there. And you can see here, these are all kind of under that, the Chaos mesh. And kind of look at this, go, great, you have to have another one there. But what's nice about this is Chaos mesh is kind of a tool out there already outside of Azure Chaos Studio. And what's nice about it is Microsoft's not trying to recreate that and say, oh, hey, we can do that better. No, we're just going to leverage all the great stuff that Chaos mesh already does for Kubernetes clusters. We're just going to kind of, this could be more of an orchestration, so it'll go across that. The other one too is like StressNG. That's another one too, where it's basically a way to kick those off. So almost think of the Chaos Studio as like an orchestrator of these experiments, and you can go there. There's one in private beta right now. I probably shouldn't even mention, but I'm really excited about it. It's one actually my kids use. It's the Not My Fault. No, I'm just kidding. That's be coming soon. So no, that's but these are some of the faults there. So let's see. Any questions up there? So when kind of going through this and looking at it, I think one of the key, I don't know if it's a gap, but one of the things that like the experiments are really well like kicking off the problem and breaking stuff. But the one thing it doesn't do a great job is like saying, okay, well, how do I know that my application is actually still working? Or, they run the experiment and then the experiment's over. But like, how do I know it like did something good, did something bad? That's where I think there's a little bit of a gap in that. I think that's where even the, this kind of joint presentation tonight, I think fits in pretty well. But, one of the things is, like when we're talking about still working, is it still functional? From a, what we're talking a lot about the infrastructure side of resiliency and but there's a whole nother side of this from an architectural standpoint, from a cloud, like making sure like, we architect the system in a way that handles resiliency. And that's like, retries, circuit breaker patterns. There's a lot of things that can be done on the application side. Even like, if like maybe our application has like 10 services it calls and we're displaying them in the UI, traditionally, if one of those failed, our whole app would be down. When we're talking about architecting it for resiliency, maybe that one service isn't critical. So everything else in our application works just except for that one feature. Maybe that box is grayed out on the screen. That type of thing, I think is what we're talking about there. But you don't really know that in this case. So what are some different ways to verify this? One of them that I think the documentation even kind of mentions is the application insights availability tests. So I did set those up. Those are okay. They're like every 5 minutes. I don't know, my test I think ran for 10. So like that doesn't really give me a huge window to know is my application down. Plus they're usually more of like a ping test. You can put some other kind of tests in there, but not hugely. So I think it's okay, but I don't think it's great. The other option, or a couple other options of using like UI automation, it's like Selenium tests. While you're running your experiment, you could be going through your site and running your regression tests. To me, that's a great way to know, does my site still work in all these functionalities while it's being broke? I put RPA there, robotic process automation, very similar to UI tests, but more around the business processes. Another thing you could run there could be that. And then the third type is around like your load testing. And so, or it would be another thing to do is to see how the application works from a load testing perspective. So that's another good way, I think, to really see how your application's working. Because a lot of these pieces that you have from a redundancy standpoint also help from a performance. So you'll know, is your application being blocked? All right, so ready for our first demo there. Any questions at all so far on Chaos Studio?
I don't see any, mine.
Sounds good there. All right, so let me jump in here. So we're gonna go create our first experiment. So as any, experiment today, we should put on our safety goggles. I'm just kidding. Can't see with them actually. All right, so let's switch over. Here. To our Azure. Let me just bring this up. All right, so the first thing that I wanted to show was kind of our environment. So, thanks. First thing I want to show is for our system that's going to be kind of under test here. And so what I set up was an AKS cluster, pretty basic cluster. We've got 3 nodes. I did actually just install essentially we have a pipeline with a deployment that installs this weather API on there. And that's really what we'll be testing. So nothing real fancy, but it's effective and shows what we want to do here. But so this is our kind of application under test, if you will. So let's go here and look at Chaos Studio. So Chaos Studio, you can search for it here. It's not like a new resource you create. So you would just search for it there, and then you have Chaos Studio. Once you come into the Chaos Studio, you can see we've got those 2 kind of main artifacts here, the targets and the experiments. So let's go into our targets first. Here's where we can actually say, like, what do we want to actually enable for our experiments? And the main thing we want to do is our AKS, and I've actually enabled this already. You can see it's actually disabled, and then our status here for our service direct is enabled. These, you can see there's the agent-based over here. Those are not, well, this VM scale set is not enabled. We're not actually going to do anything at that level of this, but that could be something we'd want to do. See how AKS handles the VM scale sets, being shut down and doing some things there. But for this example, we're just going to use AKS, and you can see I've already enabled that from this perspective. Now on the experiment, I have one already created, but we'll go ahead and create a new one here. And you can see this looks a lot like creating, different resources. In this case, we'll go ahead and create this and create it in our same Chaos demo resource group. And then so we'll do a G demo. Not all of the regions are available at this point because this is in preview. You can see up there. We do have Central US. It is free to use right now. I think at least until or through April. I remember hearing, so that's one kind of cool thing is after that, it's going to be more kind of a consumption based. So here then we get to the experiment designer, and here's where we can set up like our steps and our branches. Our branches are really if we want to do things in parallel. In this case, it's kind of just redundant. Like this one will be kind of our AKS. We're going to actually do a pod failure on this one. So we'll just do like a pod outage. And then this branch is more just the AKS part of it. Then within our designer, we're going to add in a action. And that action, again, could be a time delay or the fault. So let's add a fault. We're going to now get our list of all of our faults that we have available. You can see there's quite a few of them that we briefly talked about earlier. The main ones we're focused here are the AKS ones. And this one I want to call some pod chaos. Just kind of a fun word. Here we can set the minutes of our duration. And then we have this thing called the JSON spec. So this is something that's going to be, the JSON spec is really part of the chaos mesh in that case. And so there's a specification with it. In our case, my mouse is doing something weird. Let's see. So in this case, I just kind of have the JSON set up, but there's where you can control a few of the settings in here. More specifically, in this case, we're just saying do a pod failure. This mode, I believe this means like one at a time for how long it's going to be done. And then this is going across the default namespace in our Kubernetes cluster. So there's a lot of settings here. That's something I haven't even had a chance to dig into yet, of all the details of kind of the getting, I'd almost call it getting under the hood from a chaos mesh perspective. But that's where we'll eventually be able to dig into that part. Here now we can look at our target resources. In this case, I'm just targeting AKS. And then now we've completed everything we want to. So let's go ahead and review and create. And again, this is just like creating any other resource in there. And then we'll create this. And this will take just a second. And we'll actually create our first chaos experiment. And you can see it's done. And now you can see it's here. I'm just going to back up. Never like look at them through the deployment piece of that. So back here, and it looks like it's hidden. There it is. All right, so now we have our two experiments. So we can actually come in here to the experiment, and then I can actually kick that off and run it. We'll go ahead and, oh, before I do that, how do we know it's actually doing something? Let's pull up our Andy Cloud shell. And let's do a full get pods. And so this will show our two so it wakes up. There's our two running pods. So we'll go ahead and just do a watch on this. So we're going to see anything changing, and then we'll go ahead and start our chaos and see how that works. And so what this will do is actually randomly start getting rid of our chaos pods. I'll start here and just, oh, failed. That's great. It's not a real demo if something doesn't fail. Insufficient permissions. All right, so great point. So one of the things I had mentioned is you have to enable the resources, but then you also have to give them permissions. So let's so our AZUG demo is essentially the identity that got created, the service principal. So let's go to AKS, access control, role assignments. Just come up here and add a role assignment. And then we come down here to the cluster admin role. We'll then search our AZ user. There it is. And we'll go ahead and reassign that. All right, so now we have permission. So it's been enabled and we have permission. So that's some good security to make sure we can't just go do this to anything we want to. Whoops. Let me come back into our, sorry about that. Come back in here to our Chaos Studio, back to our experiment. Let's try this one more time. All right, so now it's pre-processing. You come here and see a little bit of details too. There's not a lot, unfortunately, of details. That's another thing that we should kind of would see, like it would actually show like a log of, oh, hey, I killed this one. But you can see here now, it just restarted one of the pods. And you'll see it'll do another one. Every 30 seconds, I'm guessing. And so you'll see some restarts here, just the random ones. Gotta see, I'll show up for like one more minute here. And there you go, if you see a few restarts there. And so that's how you can do this. And so what we want to do is make sure that our application is still running while these pods are essentially being restarted. And the nice thing about Kubernetes, right, is you basically define your replica set of how many pods you want to have running at any given time. And so if this is killing one of them, the Kubernetes service is going to go, hey, I'm supposed to have 2 of those running, and it will go start up a new one. So we'll always try to keep the 2 running at any given time. And so, we just would want to make sure application is running there. And we'll verify that here in just a few minutes when we do kind of our double demo. All right, over now. Any questions? Any on the chat here? So let's jump over.
Nothing yet, Mike.
All right. All right, so that's how we can kind of start setting up our Chaos Studio. So now let's then see, okay, well, how do we, we talked about that. How do we actually verify that? That's where this load testing service comes into play. Because John mentioned at the beginning about how the load testing service, there used to be a load testing service well, I think it was VSTS at the time. That was kind of baked into, Azure DevOps, and that has been kind of removed now, and it's more of now they're working on making it of a full standalone service. And so let's kind of show that. Before kind of jumping into load testing, just to kind of review, there's some different types of load testing that we can do. First one being performance. Think about that as kind of like the raw speed of something, like to get from point A to point B. This might be like a page load, but really for one user, not for any particular load beyond that. We talk about load tests. Those are probably the most common, just load tests that will check to see, based on a certain amount of load, how does the website perform? There's also things like capacity load tests. Those capacity load tests they're similar kind of tests, but their goal is to keep increasing the counts of those to find out what is kind of that max capacity their application can support. So like, what are the max number of users there? Stress test is another way of looking at it. That's actually now we're sending in more than the application can handle, and we want to see how it handles under the stress of too many users. And the last one is a SOAP test. What that is it's similar to a load test, but a lot of times, issues can't be found by running a 5-minute load test. When you're running in production, uptime is key. Your application sometimes runs for days, weeks, months before any kind of like restart. Same with this test. This is a test to go like a day or a week and find out if there's things like memory leaks and such there. So those are the different kind of load tests. We're really just kind of focused on this kind of main load category, if you will, there. So the load testing service is really nice. It actually leverages what's called JMeter tests, or Apache JMeter. It's an open source standard for writing load tests. And Microsoft used to have, well, they still maybe have it in 2022, I can't remember, but the one of the early betas did. They had the Visual Studio load testing tools inside of Visual Studio, but they really hadn't got much, improvements over the years. And Microsoft a few years ago decided to actually stop supporting that, and they said by Visual Studio 22 those would actually be removed. I'm not 100% sure if they have or not, but essentially they've said use different standards like JMeter, and they've kind of thrown more support around that. So instead of basically creating some sort of competing tool, they're just saying, hey, let's all use JMeter. The JMeter service itself, takes in that JMeter script. It has what's called test engines, which are essentially like your agents out there. They'll actually run your virtual users and your tests there. And then it will run against different resources in Azure. One of the nice things, though, is that, and this will bring back like your client statistics. So like your page load times, things like that you think about when you're looking at a load test. But I know, like, when I've been doing a lot of load tests over the years, it's one thing to look at the client side statistics, but I also want to look back at the web server, and see how's that performing. Is that being pegged? Is that just twiddling its thumbs? How is the server side handling it? And with the load testing service, you can actually connect in your server side components and actually get kind of a full 360 view of how the load is actually affecting your application. So I think that's pretty interesting there, and we'll show that here for right now. So not a lot to kind of show there. It's pretty straightforward from a kind of background standpoint. So let's kind of jump in and take a look. We'll switch back over to Azure. All right, so with this one, so we're still running our, I think our experiment should be stopped now. Just finishing out, because I think it was a 10-minute one. So it looks like we have 3 more minutes on that. So we'll come back to here. But what I want to show now is the Azure load testing. So this one is an actual service you create. So you can come in here and do Azure load test. And there it is again, preview. And with this one, very similar to how we've created others. Let's put this in the load testing. We have our instance name, and then the instance name, and then the region. Again, we just have a subset of regions, even less here. So hopefully by the time this goes GA, this will be available in more regions. But in this case, we're just here. And there's probably, because a lot of all that extra infrastructure that's out there. And that's really the settings, just tags and then review and create. So instead of doing this, we'll actually go and just look at the existing one I've already created. So we'll cancel this. And then we'll come in here to our load testing resource here. And so here's our tool in this place. So one of the things when you set this up, when you create a new one, I'll actually get a permission here, just like we were doing with that experiment. One of the things that is kind of nice that they make you explicitly do is set that permission out, those role assignments. One of the things about load testing is that this is probably going to be the interface that's being used by different people than the typical Azure portal kind of RBAC, admins, if you will. So you want to set up some sort of user group for these load test users so that they can come into the portal and still use this tool within Azure, but not necessarily have access to everything else within there. So that's why they kind of require you to set that up, which I think is interesting. The other part of this is the setting up the tests. So let's go just look at a test. Here I have this weather forecast test already created. We'll go ahead and create a new one here. So our test name, we'll call it our weather forecast AZ demo for this. We'll skip the demo. We'll skip creating the test after creation. We'll come here to the test plan. So the test plan is actually our JMeter script. So let me jump over here to JMeter. Not seen it. Very similar tool. It's like what the user group, or sorry, the user group, the Visual Studio load testing tool created. So in this case, I have my overall test plan. I have how I want to set up the users. In this case, setting it up for 500 users with this. I'm actually having this run infinite because I want to do like a time test versus like I want 20 users to go for 5 minutes. And then I have the test that I want to actually do. In this case, it's just a call to my public IP address that I've exposed on my pod here. /weather forecast is my URL. And then there's some what's called what are they called? The listeners to actually bring back the results of the JMeter test. And so essentially we're just saving this file off, and then we can come here and navigate to it. There is my file we just looked at. And just click I'll save it just to make sure. There it is, updated. I've been playing around with the users, so in this case we'll just go 500 users. Uploaded it. We'll come over here to the parameters. So I could parameterize this like to the environment or other things. Maybe I pass in the number of users so I don't have to go keep editing that file. So there's a lot of things I can do from a JMeter perspective. And if you have somebody that's more of a JMeter expert on the team, they're going to be saying, oh yeah, do this and this and this, and they'll be providing those. This is our engine instances. You can see here we can basically set up the threads to kind of 250. I guess I'm at 500, so we'll technically be going over that a little bit, but that's okay. The criteria, this is actually pretty cool because what I can actually do is kind of set this more like a test. At the point I can actually say, make sure that the average is, if the average is greater than, let's just say like 5 milliseconds. Well, it's probably a little much. Let's just say a second. It will actually flag the test as failed. So I think this is a great way. I'm a real big believer in like continuous testing of this stuff. And I'll talk about that coming up here in just a few minutes. But this is a great way to show like, hey, this has been running and all of a sudden now failed. In this case, I'm not going to actually do that. The monitoring piece, here's where we can now hook into some of those resources. I'm going to actually hook into App Insights because App Insights gives me some CPU and memory metrics from that. And then the other thing is the cluster that my application's running under. But there could be, I could set up more of these if we really wanted to, but those are the main two for this instance. All right, so we've set that up. We'll go ahead and review and create it. The other thing I want to come back into, I just love these asynchronous tools that don't automatically refresh. I want to come in here before I do this, and you can actually come configure. Maybe I have to do a test first. That's interesting. So let's go look at the other one I did, and I'll show you. Or maybe that's not working right now. They mentioned this is in preview. Oh, so one of the capabilities is these metrics is really nice because you can actually come in here and specify not just the app components of the test here, but then when I come over here to the metrics, I can say what I want to actually view. And here I can show you with this existing run, some of the types of things I'm talking about. So you have, oops, let me let that refresh. So down here, you have some of these server-side metrics, like from an AKS perspective, it's saying how many CPU cores, like the response time, and then so you can see this changes in Netapp Insights. So the ones I've added was like the response time, how many failed requests do I have, how many server requests. So you can add in those different metrics. Normally you can add them. I'm not sure if I click on here. Okay, so I can actually get to them from this view. So you can actually come in here and actually add those. So App Insights, I can choose which namespace and then the different metrics that I want to add. So typically you don't just do it here, you do it outside of that. All right, but that's okay. So there's kind of that I'm running there, or I'm sorry, that example. So let's come back in here to our demo. We now have a test for 500 users. Should have still enough money. I didn't run some of these tests because I didn't want them using up all our credits here before our demo. So this kicked off the test. You can see there's my test run. This is actually going to kick that off. One of the really nice things here that I want to show, let me switch over to here, is this will show some pretty nice metrics. But what I really like, if you guys have used App Insights, this is then 100, so that's pretty good. That should get us by to the end of this. If we come here to the live metrics, this is a really good thing. I mean, this is just good to run while your site's running, but especially when you're running a load test, I think this is really interesting. So one thing you'll notice, we've got 2 servers online. That's our instances of our pods. We do have this set to scale. We have the horizontal pod scaler there, so you can see like the request rates and some of the like CPU here running on the 500 tests. At this point, we're at about 50%, so that should probably trigger some of these to go up. But our response rate's really good. You can see it's here down below a half a millisecond. I'm able to do the request that fast. So that's some of the stuff you get from App Insights, which is pretty cool. You get very similar here. You can see some of the view. It's just not quite as exciting. But here, if you notice down here in my containers, all of a sudden now it's spinning up some additional containers. My horizontal pod scaler is actually spinning up additional instances for this test. So that's pretty cool. That's another thing you want to test and verify. So you can see the like request per second, and then now it's starting to drop down because we're bringing up more instances of it. We don't have any failed, which is good. Our server requests, I don't know what that means. I'm not sure what that one is. But you can see some of these metrics don't really show until the end. But you can see the virtual users, it's got up to that 500 limit, and it's been chugging right along. And I think we set this for 5 minutes. So yeah, 300 seconds. So let's run for a few more minutes. Oops, I can come back here and kind of look at this. Now you see we have 10 servers online, and you can see we've got a number of the pods there. So that's a great way to show. I did configure the pod, the auto scale correctly, and it's scaling. You can see the trend now starting to dip back down below 50. Any questions on this? All right, so we'll let this kind of finish out. I think that was.
Hey, Mike, John has his hand up. John, you wanted to ask something?
Uh-oh.
Sorry, guys, can you hear me okay?
Yeah.
More of a comment, really. You just brought in some metrics things there for resources, but it looked like you could add things like Cosmos database, SQL Server, those kinds of other things. And I think what's really cool about this is that you kind of had that dashboard view where you had all your metrics and things brought together. You can get one quick view of how the whole system is being affected by your test.
Yeah, you're exactly right. So if my system actually had a backend database and had the kind of the full components of your system, you can bring all of those in and get the full metrics there to see how that's all performing and see not just how it's performing, but see like where the bottlenecks are. Yeah, that's a great point, John. Thanks for mentioning that.
Yeah, versus having to go out and look at everything individually. Hey, what happened to my Cosmos? What happened to this? It's all kind of right there in front of you.
Yeah, exactly. Yep. Yeah, good point. All right, so that'll get that, and we'll come back and check on the instances. This should drop back down to 2 once that is done. So we will switch. I think that was everything I wanted to show. Yep, and that will get you all Yep, that's what we can show. And you can see here, still chugging along pretty good there, but we're going to do better next time. We're going to do more. All right, here we go. So for this last part now, kind of bringing this all together, it's like, this is great to do this from my machine or from a single person's machine, but like, let's run this consistently and see over time how our application is actually doing performance. So how does this fit into pipelines? I think the first question might be is how often, right? We have application pipelines, or do we run with an application pipeline? So like, let's say we're deploying our app 10 times a day. Should we be running these load tests and chaos experiments 10 times a day? Should we run them nightly, weekly? How about if we do like quarterly releases? Hopefully nobody does that. But if you do quarterly releases, do we just do them right before the release and just make sure everything's good? and hope that we have time to fix it if not. So those are kind of the questions we ask. So looking at that, though, we have some kind of different pipelines, right? Our application pipeline, again, we're really shooting for something fast within 20 minutes if we needed to go all the way to prod. Usually we're deploying like a small part of our application, microservices or the front end of that application, but we're deploying like more like app-centric infrastructure, not everything. So, and if you look at those tests, even like the comment John made is those are more of a holistic view, right, of our whole system, not just one kind of piece of this. And that's where I think application pipelines probably aren't the best fit for these. I think what you could do is set up your own chaos pipelines. I mean, that just sounds cool, right? You could run this daily or weekly. We've done some projects where we were actually running load tests every single day. And the nice thing about that is, developers are making changes to code. We can see how that code is impacted or impacts the performance of the application on a daily basis. Just like a bug, it's a lot quicker to fix something, the next day or the other day that it did versus, weeks or months later. Maybe you don't have that many changes going on. Maybe weekly is okay there. I do think this is a better fit for that. This isn't, a must-have, but this, to me, I think it's about thinking about it differently. Traditionally, load environments have been the separate thing that nobody touches. To kind of see what we're doing from a performance standpoint, we do kind of need that prestige of something where nobody's touching it just to see. But if we're running these over time, that's how we can actually identify how often our resilient or how often our performance, I guess, there. And the other thing too is don't just do it, as I mentioned, daily. Don't do it at night. Do it while your testers are in there. I think there's always been a fear of doing these kind of tests at night so we don't impact anybody. Well, the whole idea is we eventually want to get to prod and not impact people. So if we don't feel comfortable doing this in test, we're not going to feel comfortable doing it in prod, right? Or we're not going to feel comfortable or chances of success if it happens in prod. So that's kind of where, I've seen it, and I recommend you just based on, what I've seen so far with the tools there. And then last thing, sorry, this is, to me, building confidence to even do it in prod. I wouldn't start there unless you're looking for a new job. But get the confidence in your test environment and then, show how you guys can test some of these in prod. Your auditor comes in and goes, oh yeah, we just finished that test, making sure that everything, switches over if there's an outage. And I'm like, whoa. So you can do that earlier there. So the last thing I wanted to show here was how then we can actually kind of pull all this together. So switching over to our Azure pipelines, I wanted to show we have essentially our repo here of our weather API, and in this we have our chaos folder with our pipeline for that. So let's switch to pipeline view. In this case, we have our chaos pipeline and our weather API. Let's look at our chaos pipeline and edit that. And in here, I have a pipeline of really two things, one after the other. So the first thing we're going to do here is actually run our experiment. And so the experiment supports, you can either do it through the portal or doing it with like Azure CLI. In this case, you see I have an Azure CLI task in my pipeline. We're basically passing the subscription, the resource group, and the experiment. And then it's calling the REST API to actually do that. At some point, there might be a nice, neat wrapper around this for doing that, but for now, this worked out pretty well. The one downside is this was just a fire and forget. So if we wanted this to actually still run for that long of a time, we'd probably need to do another REST call to check on the progress to see when it was actually done before it finished. In this case, I just did it as the first step and then let the Azure load test kick in. And here I specify the load test or the resource group, the load test resource that I have, and then this config file, which really just specifies like the JMeter test. So the one downside is I did find a bug in this. This is not actually running, so unfortunately it's giving some weird error. I checked just a little bit ago to see maybe if they've updated it again, but they updated it this morning, of course, and I think that's what broke it. So hopefully that'll get fixed. I did log a bug on GitHub. We'll see on that one though. So I can't actually run this fully, but we're going to still run it. We're going to kick off this pipeline, and then we'll just kick off that test manually. So let's actually, I wanted to do this before, but we'll crank this up to 2000. And I couldn't do that because I was a little fearful that I would run out of credits. But let's go to our test. Update either one of them. Let's configure the test. Let's come run, update our test plan. Move that. We'll upload this new one, 702. And so there's our new test. We should maybe bump this up. I've never actually tried that. So let's bump it up to 2 and just see how that works with that. All right, so we've applied that. I'll kick off the pipeline for our test. Actually, you can see here, looks like the pods are terminating just in time to get started back up again. But we'll go ahead and, so this runs for about 5 minutes. I think the other one runs for about 5 minutes in the pipeline. So about to wash. So let's switch over to our pipeline. We'll go ahead and run. We're running out of this branch for now. And you'll see this will just finish, and then maybe the other task is fixed. So we'll try it from here and see if this works, but I'm pretty sure it'll fail once we get past the this one should succeed. Yep, and then this one failed with very bizarre, can't find a task module. So let's switch them back so that is starting to do its thing. We will go ahead and start our test. This is the one that we modified. I think it was. Hopefully. So we're going to kick that off like it was actually running from the pipeline. We'll refresh the view to get our dashboard with it. We'll see if we the users go up to 2000. Let's see if this is the right one. I'm hoping to actually see some failures. Maybe 10 instances isn't enough. All right, so there it just started up. You can see there, it's the time period's going up quite a bit. This still isn't showing there. Oh yeah, there we go. Virtual users 2K. All right. Our response time went up to about half a second there. Oh, it's dropping down, so it's handling the load. That's good. Here, see kind of the performance is a lot more staggered than it was before. Still at 2 servers. It hasn't shown that it's increasing yet. And let's take a look here. You can see it's starting to terminate some of them. It's starting to create new. So it's trying to chug along. All right, we did get some errors. Let's see if we're seeing those in our. Yeah, we're not seeing the error messages in that. But that's good, right? We're trying to kind of break it. So we're getting some error messages. And probably a lot of this is because of, it's trying to run them and then the pods are actually starting to go away. So in this case, this is showing us that our application's not necessarily the right level of resiliency for this type of load, and that we'll need to do something to kind of help make that a little more resilient. I was hoping to see those request failures here. Not sure why we're not. Unless they're actually in AKS and not in, we can't really see AKS here. We could, one of the nice things about AKS is it has container insights. So this just shows us at the node level. So you can see I got some spikes up there, but really not much, which is kind of what I was expecting. I don't think, even though our pods are spinning up, I don't think overall it's much much work there. So there you go. Now the requests have kind of leveled out. So we've got our 10 servers running. You can see it's running pretty smooth now. See CPU wise, it's kind of all over the board of how much they're being utilized. And then I wanted to come back here and just see if we're still getting more errors. 707. So I got an error about a minute ago. So hopefully we wouldn't see any more errors from here on out now that we know it's kind of leveled out. So we could kind of let this run out for a few more minutes. That's really what I wanted to show for tonight. So any questions at all on Container Insights?
There is one. Robert is asking, is there a good way to update or configure the tests using Azure CLI instead of manually uploading the tests?
So that's through the pipeline. You can do that. So I can actually control. Yeah, great question. So the thing I didn't show here is this YAML file. So in here, there's this weather forecast YAML. This will actually help control that. There's a lot more that this file offers. And so you would control it through here versus the CLI. I'm not sure on the CLI. I didn't see any because when this failed, this task failed, I looked to see if there was a CLI option in there. I'm sure there probably is some sort of API with it. But this is how I would probably recommend doing it, like without going through the app. But yeah, you can see here is the JMX file. And then this isn't pulling the one I uploaded. This would pull this file right here in this folder. So that's how you could kind of do that outside of messing with the portal. Yeah, great question.
Yeah, I don't see any other question on the chat. So if there is any questions or anything you would like to discuss with Mike, feel free to unmute yourself and you can ask Mike directly.
Yeah, I haven't heard when they're coming out of GA or anything like that. Like I did hear him say though that it's free through April for the Chaos Studio. So that maybe it'll go GA in April, but I haven't really heard either way.
Yeah, once it's go GA, be aware of the pricing. Right now it's free. Once it's go GA, then Microsoft will start charging for this. All right, if nothing, then on behalf of the user group, Mike, I would like to thank you once again for taking out time for presenting today in the group. This topic was great and it's pretty new. It's in preview, as you said, but it's great and learned a lot today. Thank you once again for presenting.